In this video, we will discuss what lattice energy is and how to predict and arrange ionic compounds in order of lattice energy. So, lattice energy is specifically the energy released when an ionic bond forms. So essentially, the stronger the bond, the more energy that will be released. And how strong an ionic bond is goes back to Coulomb's law. So Coulomb's law down here says the force of attraction is directly related to the charge of your two substances multiplied by each other divided by the radius or the distance between your two charges. Okay, and so if we have positive and positive, those repel. Negative and negative, those repel. But positive and negative, they attract. And then if I have two positive and negative, this attracts more because this positive 2 has double the positive charge as just a positive 1. And then if we don't have a charged particle, then positive is not going to be attracted and negative is not going to be attracted. Okay, you have to have opposite charges for there to be attraction. Okay, so that is one part of Coulomb's law. The second part of Coulomb's law talks about the distance, and since distance is in the denominator, a large distance would actually lead to small attraction because you plug in a large number to your denominator, and mathematically that will lead to a lower force of attraction. Okay, so the force of attraction is directly related to the magnitude of the charges. Higher charge, more attraction. And it is indirectly related to the distance between the charges. So high distance between charges, that will actually be low attraction. Okay, and like I said, is lattice energy is the energy change that takes place when an ionic bond is formed, or here, just kind of the opposite sort of definition. It's the change in energy that takes place when you separate an ionic compound, okay? And so lattice energy has the same equation as Coulomb's law, except that the distance is not squared in the denominator. And in this class, we're not doing any of the math here in terms of plugging in numbers and solving. Okay, so again, the size of ions and the charge of ions are going to be the two things that we're going to consider. And so the larger the ions, the larger distance between the two nuclei. So if I have a nucleus here and it's got multiple different energy levels, and I have a nucleus here with two energy levels, there's some sort of distance between them. But let's say this goes to something with three energy levels. Naturally, there's going to be more distance between the two nucleus, okay? Or between the two nuclei, and that would lead to lower attraction. And then the charges, the larger the charge, the larger the lattice energy, and that's because mathematically that's in the numerator. Okay, so what we can do is we can answer some questions here, and I've given you some ionic compounds and their lattice energies and also their melting points. Okay, and so melting point is directly related to lattice energy. And so question number 1 here says, explain why the lattice energy of LiF is larger than that of LiI. So what I want to do is I want to find it. And clearly that is true, that LiF has a larger lattice energy. And what we want to do is compare what's the same between them and what's different. And whatever is different between them, that must be what's causing the difference in the lattice energies or the melting points. So how I do this is I find their charges. Lithium has a +1 charge. Fluorine has a -1 charge, and iodine, being in the same family as fluorine, being a halogen, has a -1 charge. And so the charges are the same, and so what we would want to do is we would want to write that out. The charges between the two ions is the same. Nope. But what is different? Okay, lithium is obviously the same between them, so we don't need to really compare that. But fluorine versus iodine, if I draw a picture here, lithium ion actually just has one energy level. Okay, so maybe it looks something like that. And then fluoride has two energy levels, so maybe it looks something like that. There's this distance between them. Again, lithium has one energy level. Iodine, if I look at it, it has 1, 2, 3, 4, 5 energy levels. So what this will look like is 1, 2, 3, 4, 5. It's really large, and so there's a huge distance between them. So the charges between the two ions are the same, but iodine is much larger than fluorine. Thus, the attraction between Li and I is much weaker than the attraction between Li and F. Thus, LiF has a higher melting point and lattice energy than LiF, okay? Now, when we go to and do number 2, it says, explain why the lattice energy of sodium oxide is smaller than that of magnesium oxide, okay? And so these are on here. Okay, so why would sodium oxide be different? Well, sodium is a +1, oxygen is a 2-, magnesium is a 2+, oxygen is a 2-. So my guess is it has to do with the charge, but we also have to compare energy levels. And so sodium ion has 2 energy levels because it's Na+1. Oxygen ion or oxide ion has 2 energy levels as well. Magnesium ion, because it's Mg+2, it loses its 3rd energy level and has 2 energy levels. And oxygen has 2 energy levels. Okay, so what I would start out by saying is okay, but then I would add okay, and an answer like that would be all that you need. So compare what's the same between them, what's different, and why does that difference make a difference.